Our last example that we're going to look at from your Chapter 16 exercises has to do with this used car dealer, and they have a two-step process to get their cars ready to sell. So they have their mechanical checkup as well as their appearance prep, and it gives you a lot of information about those two stages, like the cost per hour, the average time it takes, and then again a measure of spread, a standard deviation, so it gives you kind of that variability for each of these two stages. All right, and the first question that it asks us to do is to find the mean and the standard deviation for the total time spent preparing a car. Now, you're going to see that a lot of the work we're going to do is going to be very similar to what we did with the roll the dice game. But I want to be very clear that these are two very different types of scenarios. In the roll the dice game, that was what we called a discrete random variable. The reason we say discrete is because there are distinct values for the possible outcomes. Remember, if I rolled a 1, 2, or 3, I had 0 points. A 4 or a 5 was 5 points. And then if I rolled a 6, I got 50 points. So I only had 3 options in this game. I get 0 points, I get 5 points, or I get 50 points. That's it, right? With this example, we literally could have any amount of time that it takes to do these two stages, right? I know it gives me an average of 90 minutes and 60 minutes for each of them, but it could take anywhere from just over 0 minutes to however long it's going to take. So again, we would call this continuous random variables because there's not an exact range of values. It could go on forever. Okay, so know the difference between those two, but again, you'll see the work for our purposes is going to be pretty much the same. All right, now there's one other thing we need to do before we actually get into this problem, and that's where we need to think about, are these two stages, right, these two different processes, are they independent events? All right, so what I'm saying is if they're getting a car ready to sell at their used car dealership, is the time that it takes for them to get it mechanically ready, right, the mechanical checkup part, is that time related to how long it's going to take to do the appearance prep, the car wash type prep? All right, and so for our purposes, you might think, yeah, there's something going on there. But for our purposes, we're going to say that they're independent. So no matter how long it takes to do the mechanical checkup, it's not going to affect how long it takes to do the appearance prep. So these are independent events, independent random variables. Again, random variables being because it can take on any random number. All right, so I'm going to go ahead and define a few of these random variables. I'm going to let t equal the total time. I'm going to let m represent the mechanical checkup. And then I'm going to do a for the appearance prep. All right, so I'm going to use those 3 variables to figure out this first question, which says to find the mean or the expected amount of time it's going to take to spend preparing a car. So that means the mechanical part and the appearance part. And then define a standard deviation associated with that, because yes, we want to know how long we expect it to take, but also to give me an idea about the range of values. All right, so I'm going to go ahead and do t equals m plus a. So again, showing you that I'm going to add these random variables. Well, in order to do this, I want to find the expected value. So I'm going to write e of t, and I need to add the expected value for the total time for mechanical plus the expected amount of time for the appearance prep. And we were given these numbers in the previous slide. We were given that it takes 90 minutes on average for the mechanical and 60 minutes on average for the appearance. So I'm going to write our 90 minutes plus our 60 minutes. All right, and that will give us the expected value for the total time, which is 150 minutes. All right, or 2.5 hours, right? If we think 60, 60, and then the extra 30. So 2.5 hours on average to get a car ready to put, I guess, on sale. All right, so now for the standard deviation, again, just like we did with our dice game, whenever we find standard deviation, we always want to first find variance. Okay, so I'm going to write here that I want to find the variance of our time t. All right, and again, as I explained earlier in the dice game, and then I explained in the lemonade example, that we're going to always add the variances. Okay, so make sure you just, again, always remember that. Variances add. Okay, so the standard deviation for the mechanical checkup was 15 minutes. So I'm going to write 15 minutes. But again, that is the standard deviation. So if I'm dealing with variances, I need to square it. Okay, same thing for the appearance prep. It says a standard deviation of 5 minutes, but again, I'm working with variances, so I need to square it. So what's 15 squared plus 5 squared, so that is 225 plus 25 is 250, but that's squared minutes. All right, so I don't want squared minutes. I want just minutes, which is going to be our standard deviation. So I'm going to write the standard deviation for the total time is the square root of 250, which I'm going to use my calculator here. The square root of 250. So square root of 250 is about 15.8 minutes. All right, so that is my standard deviation, 15.8 minutes. All right, so we would tell whoever's curious about this, whether it's the actual auto place or maybe a customer, that the average time it's going to take to get a car ready is going to be about 2.5 hours, and then with a standard deviation of about 15 minutes, a little over 15 minutes. All right, so that's the first part of this example. The next part of the example has to do with, well, okay, you've given us the cost per hour for each of these two stages. So now tell me, what is the expected cost or expense of preparing a car to get it ready to sell? All right, so again, we're going to be dealing with our different random variables, and we need to make sure that we are assuming they're still independent. All right, so that the cost of the mechanical doesn't affect how much it's going to cost to do the appearance. Now, the cost is based on the time, so if we think that they're independent in terms of the amount of time they take, we can still assume independence for the expense of preparing a car. All right, so I'm going to use those three variables again, but this time they mean a little bit different, right? I still have T, but I'm going to talk about that being the total cost or expense. I'm going to have my M, which is the mechanical, but I want to make sure you guys know that this is now going to be, because we're dealing with cost, they gave me, I'll go back a few slides and show you, they gave me the cost per hour. So notice on this first one, it was the mechanical and appearance, and I used minutes, right? The 90 and the 60 is minutes. All right, but here I need to be looking at the mechanical in terms of hours. All right, so it's going to be a little different. And same with the A, that's going to be my appearance in hours. Okay, so I want to find the total expense or total cost, the expected value for my total cost, which is going to be my expected value for the time in hours for mechanical. So if it is 90 minutes for the expected value or the expected time, the average time, then the average time in hours is going to be our 1.5. So I'm going to have my 1.5, right? So that's a mechanical in hours, so 1.5. All right, and then for the appearance, it says the average time it takes is 60 minutes, right? 60 minutes. So I'm going to go ahead and say that that is 1 hour. All right, so plus 1.0 hours. All right, now again, each of these phases costs money. So it says for the mechanical phase that it's going to cost us $50 per hour, right here. And then for the appearance phase, $6 per hour. So I'm going to have 50 and 6. All right, so I'm going to go ahead and go to my calculator, and I've got 50 times 1.5 plus 6 times 1. Probably don't need to go to my calculator. You guys probably do this in your head. Plus 6 times 1. So it gives us $81. All right, so that is our expected expense for getting one of these cars ready to sell it. All right, so the process of mechanically getting it ready and then making it look nice. So $81 is what we expect for the total expense for a car. So now we need to find the standard deviation. Again, since we're finding standard deviation, we need to work with variance. All right, so I want to find the variance first. Now this can be a little bit tricky. So first I want to find the standard deviation for my mechanical hours and my appearance prep. So that was given to me in minutes, but I don't want minutes because we're talking about our price is in per hour. So I need to basically take that 15 and that 5 and put them into hours. So I'm going to divide each of those by 60 minutes. All right, so I have 15 out of 60, and I've got 5 out of 60. Now that's the standard deviation, so if I want to work with variances, I need to square them. And we're always going to add variances. Now this again is a little bit confusing. All right, since we're dealing with variance, we're dealing with squared units, it says that it costs, remember that 50, right, the 50 and the $6 per hour. I'm not going to multiply by 50 and 6. I'm going to multiply by 50 squared and 6 squared because I'm dealing with squared units here. So a lot of stuff is being squared. So I'm going to do all that in the calculator, and that will give me the variance for the total cost. All right, so I've got 50 squared. So I got 50 squared times, and I'm going to go ahead and use my fraction here. So that was 15 over, oops, let me get back into the fraction. 15 over 60. Now all that's squares. I need to get some parentheses here. No, I don't want it there. Good try though, calculator. That's where I want it. All right, I want to square that too, and then I want to go ahead and add 6 squared times, do the parentheses first, times 5 over 60 squared. Over 60 squared. All right. Why did it put an extra one in there? Let's take that out. Oh, no, it doesn't matter probably. Okay. Well, let's hope that works. Let's see. All right, it did work. Excellent. So that's the variance. The variance is $156.50. But remember, that's not in dollars. I said dollars, not in dollars. It's squared dollars. So squared dollars is 156.5. That's in squared dollars. All right, we don't want squared dollars. We want just dollars. So we'll take the square root of that for the total time. So the square root of 156.5 is going to be equal to, I know the suspense is killing you guys, 156.5, should have just done second answer. That's okay. $12.51. So that's going to be the standard deviation for the total expense for getting one of these cars ready to sell. So $12.51. Okay, so hopefully I know that was a lot longer than the previous one, but you can see that the process is the same, right? We're still adding our expected values, right? But we had to multiply this time times that constant. And when we're still adding variances, but yes, because we're multiplying by a constant, we needed to multiply by the constant squared because we always deal with variances, which is squared units. All right, so the last part of this example says, well, what if I wanted to find the mean and standard deviation for the difference in the cost of these two phases? So it's actually the same variables we just used, right? Our T, our M, and our A, but this time the expected total cost is going to be the difference between the two. So it's literally exactly the same, right? Exactly the same. I have my $50 times my 1.5, but this time minus my $6 times 1 hour. All right, so whatever that is, that's going to be our expected value for the difference. So that would be our, let's see, $75 minus $6, which is going to be our $69. That's how much I expect for the difference between these two phases for the cost of getting this car ready. And then I know you're thinking, oh, we got to do a lot of work here to find the standard deviation. We got to find the variances. We have to do all that. But again, just as I said with the lemonade example, we're doing the difference of these same two random variables. So even though we're doing the difference, we should still do what? You got it. Variances add. So it's actually the same work. I'm not going to do it again. No need to. The standard deviation is the same. Awesome. So I'm sure you're really excited. It's exactly the same, $12.51. Again, even though you might be a little bit confused, why didn't we subtract the variances? Because even when we subtract, we still have a greater amount of variability, of unknown. So that's why we add the variances. Okay, so that's that example there. I'm going to go ahead and stop now and let you guys look at quiz A.